Hi everybody. So let's look at what happens when you take a terminal alkyne. Right, so alkyne is this triple bond, and terminal just means it's on the end of the chain. And you typically don't draw them out, but here I've shown the hydrogen at the end of the chain. And the reason I've shown that is that's the hydrogen we're going to remove here in a minute. So in step 1, sodium hydride is a base. So we're going to take some base. It has to be a fairly strong base, but an amine base works well. Sodium hydride, LDA, things like that work pretty well for this reaction. And what this base does is it's going to remove this hydrogen, and what it's going to generate is a negative charge on the end of that triple bond. And the point of doing this is we're going to do one of two things. We're going to make this anion either a good nucleophile or a base. And the way we're going to determine whether it's going to be a nucleophile or a base is by where the leaving group is in step 2. Alright, so step 1, if you put a base on, you're automatically going to get this negative charge. Alright? Now, determining the mechanism, whether it's going to be a nucleophile, so SN2, or E2, is dependent on where the leaving group is. So let's go back up here. And so we'd let this stir for 30 minutes or some amount of time in our reaction flask, and then we'd add in the second group. And this bromine is on a primary. So if you're on a methyl or primary, you're going to do SN2. If you're on a tertiary or secondary, you're going to do E2. All right. So this one's on a primary. So what that means is this is going to do an SN2 reaction. So this will attack from the backside, hit the carbon hole in the bromine, and kick it off. And so now let me color code our products. I'm going to do the alkyne in red with our triple bond. Our new bond, so where the arrow, so the blue arrow, is going to be a blue bond. And then our product, we had 3 carbons, so we already have 1 there, 2, 3, plus sodium bromide. Right. And so what we've been able to do is add these 3 carbons here in black that came from here in step 2. And so we made this terminal carbon a good nucleophile, and we made this bond. So this is how we link the two together. And it really doesn't matter what else is over here on the other side of this molecule. We're just going to continue with the chain. If it had been longer, if it had only been 1 carbon, then we only had 1. Alright, so the take-home message is step 1 is acting as a base. So it pulls off this proton and creates an anion, which can either be a good nucleophile or a good base. If it's a methyl or primary, depending on where the leaving group is in step 2, it'll be an SN2 reaction. If this had been a secondary or tertiary, it had been an elimination, so E2. Alright, so let's try that again. So on the next one, we have the same idea, where we still have a base. So we're going to get our terminal alkyne to have a negative charge, and that came from step 1. Now what we want to do is come over here and look at where the bromine is. It's on a secondary, and so remember, secondary is going to favor E2. So we're going to get an elimination. And what elimination means is that we're going to take the hydrogen that's anticoplanar, and we're going to pull it off. Sorry, I don't know why I put the 2. There are 2 hydrogens on there, but it doesn't have a 2. And we're going to pull off that hydrogen, push the electrons in, and kick off the bromine. And what that leads us to is to form a double bond. And so between where the leaving group is and the adjacent hydrogen, we get an alkene. Alright, so if it's a secondary or tertiary, we're going to get an alkene. Alright, let's try another one. Same thing in step 1. We're going to create an anion, so let's draw that. Our negative charge on the end, our carbon chain stays the same. Now if we come look at the carbon holding the bromine, in this case it's still a primary. So primary tells us we're going to do SN2. So the negative charge will be our nucleophile. It'll attack, kick off the bromine in a traditional SN2 fashion. And now we can draw our product. This is the bond we just made, and now we have our benzyl group. Okay. This carbon here was this original carbon, and then since we had a sodium and a Br, we get plus sodium bromide. Alright, so the take-home message from this is, remember that this proton here is a little bit acidic, and it's acidic because of the increased S character. Okay? And so remember, the more S character, the more acidic. And because it's acidic, we could put some base in, so that's what step 1 was, and pull that off. And so when we pull it off, we're pulling off a proton, so it leaves its electrons behind, and that makes these pair of electrons into a good nucleophile or base. And then we can determine whether it's going to be a nucleophile or base based on where the leaving group is. Right? So wherever our leaving group is. And so if it's a methyl or primary, it's going to do SN2. If it's secondary or tertiary, we're going to do elimination, and in this case it's E2. Hopefully this helps.